In this playlist, we're going over predicting the products of a chemical reaction. Now, there's 5 types, and in this video, we're going over just single replacement reactions, also known as single displacement reactions. Now, we're going to have on the left hand of our screen a guideline for predicting the products of reactions. And in the blue box, we're only going over single replacement reactions. If you haven't already, you have to make sure you know about ionic compounds, how to name them, and also how to write them, because it's very useful to know the charges of ions in ionic compounds in order to successfully predict the product of reactions. Now, we're going to go over 4 examples here. There's a lot of stuff on the screen, but let's just take a look to the right now. All single replacement reactions will generally look the same, and it's actually in the name. So what we have here, it's kind of an analogy in dancing. We have a single A and a couple B, C. And in a single replacement reaction, basically the single thing is going to replace one of the other things in the couple. Okay, so A is going to replace B, and that means B is going to swap places with A. So as a result of this, B is now by itself, and A is now in a couple. Okay, so generally all single replacement reactions look like this. If you look at the left, what we have is for single replacement reactions, there's actually 4 types, and you can just go ahead and read through those types right there. But as I go through the examples, I'll just point out which one it is. If we look at the bottom, here's our first example. What we have here is zinc metal and sulfuric acid. Now, out of all of these 4 types, which one of these single replacement reactions is it actually going to be? Well, it's not the first one. It's not 2 metals. We don't have 2 metals in our first example. It's not the second one because we don't even have water in our second example. It's the third one. It's the third one because we have zinc metal and an acid. All right, so we're basically going to follow the structure of what I boxed out right here. We have a metal reacting with an acid. And you should know that acid is anything that begins with an H followed by some sort of ion. It's a good idea to write down all of the ions in a replacement reaction so that we know what is replacing what. So I'm going to go ahead and write those down now. This is where it's important to know the charges of all ions. So there are the ions, and remember, in a single replacement reaction, there's just a swapping going on. So I'm just going to swap the positive ion. All right, so this should be generally what the products look like, but I'm going to write the actual answer in blue. Now, when we have a single atom, you have to consider whether that is going to actually be one of the 7 diatomic molecules. And hydrogen happens to be one of the 7 diatomic molecules. You can go over our videos on covalent compound naming and formula writing to know what these 7 diatomic molecules are. And as for our zinc sulfate here, since both of them are positive 2 charge, we need 1 of each ion. If you have 1 of each ion, then the compound will be neutral. And this is going to be our final answer here. I'm also going to include really quickly the names of these compounds here so that it's just a little bit more practice for you. So again, the one that's circled in blue, that's the actual answer. I also wrote the names of them just for practice. I do encourage you to keep practicing writing the names of it. But this is generally how I'm going to go over the examples. So let's move on to the second example. In our second example, we have on the bottom sodium metal reacting with water. Which one is this? If you take a look at the list of the 4, the most likely candidate for this is the second one. We have an active metal replacing H from water. We have the metal and the water. Again, for all replacement reactions, it's a good idea to write down the ions that each of these substances are composed of. So these are our ions and their corresponding charges. Now we're going to do a single swap. And here we go. This is what the products should look like, but I haven't written them down yet. I'm going to write them in blue. Now, hydrogen is one of the diatomic molecules, so we do have to write a 2 next to hydrogen because that's how it exists in nature. And as for our sodium oxide right here, well, since the charges aren't balanced, we're going to need 2 sodiums. All right, so those are the 2 products of this single replacement reaction. And here's their names. Let's go ahead and do our third example. We have on the bottom strontium metal reacting with magnesium oxide. Now take a look at the 4 single replacement reactions. Which one is this most likely to be? Well, in this example, since strontium is a metal and magnesium is also a metal, what we have here is a metal-metal replacement reaction. And again, for a replacement reaction, try to write down the ions first because that's going to help. So here are the charges of all of the ions, and we're going to do a single swap. This is generally what the products should kind of look like. Now, I haven't written the products yet. I'm going to write that in blue. But for magnesium, magnesium is just a pure metal, and it's not diatomic. Again, there's only 7 diatomic molecules, and there is a way you can remember them. It's have no fear of ice cold bear. Okay, and magnesium isn't one of them. As for our ionic compound here, our strontium oxide, since both of them, it's +2 and -2, since they cancel out already, we're only going to need one of each. So it's going to be SRO. All right, and that's what the products are for this third example. I'm going to go ahead and write down the names too. Okay, ready for the last example? We have bromine gas here reacting with sodium chloride. Bromine gas reacting with sodium chloride. Now, which one of these 4 single replacement reactions is it most likely going to be? Okay, hopefully you narrowed it down to the halide-halide or the halogen replacement because bromine and chlorine are both halogens. So it's kind of like the metal-metal replacement, except it's the halogens replacing each other. So we're going to be following this 4th one right here. With all replacement reactions, it's a good idea to write down the ions of each of those compounds down there. All right, there are the charges of the ions, and we're just going to be replacing, this time, the negative ion with the other negative ion. Okay, so that's kind of what the product should look like, but we're going to make sure everything is balanced and we account for any of the diatomic molecules. So written in blue is going to be our final answer. Chlorine is one of the 7 diatomic molecules, and as for our ionic compound, sodium bromide, since there's one positive and one negative, they cancel each other out already. So you only need one of each ion. All right, that's our final answer. I'm going to go ahead and write down the names one last time. And there we have it. Now on the next page, we're going to have some practice for you. And I would like you to try this on scratch paper and see if you've got something similar. So make sure you pause the video for this um, and try it for yourself. After you have done it, you can compare it to mine on the video. You can unpause it and just compare. Okay, now here are all the answers. If you got it right, then great. If you didn't quite get some of them right, then I'm going to explain a few of these with their ions, okay? Hey, thanks for sticking around and advocating for yourself. Now I've gone ahead and wrote down all of the ion charges so that you can kind of see how the single replacement worked. And basically here, you just want to check for your products whether you have a diatomic molecule, if it's only one element. So again, the diatomic molecules should be hydrogen, nitrogen, fluorine, oxygen, iodine, uh, chlorine is our sixth one, and last one is bromine. If you're wondering how I remember it, there's a mnemonic device for this. It's have no fear of ice cold beer. So there should be seven diatomic molecules. The other thing that you want to check is the ionic compound. For the ionic compound, you want to make sure that the charges cancel out. And if you look at all the charges here, you can see why there might be multiple of one of the ions. So I'm going to have some practice for you for single replacement reactions. Please make sure you do the practice so that you can know that you know how to do this, and I'll give you feedback for it.